Alright, in this video we'll be talking a bit about scientific notation. Now, the easiest way to understand what scientific notation is it's just an easier way to use exponents to write really large and really small numbers. Naturally, this comes in handy in the sciences where we often have really large and really small numbers. So for example, there are 366 billion gallons of water on Earth. That's a really large number, but we can use scientific notation to write it in a better form. Can write it as 3.66 times 10 to the 20th power gallons. In a similar way, one electron has a mass in grams of 0.00000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000 We can instead write it as 9.1 times 10 to the negative 28 grams. So, how does this work in practice? So, let's go ahead as an example and write the following numbers in scientific notation. Well, if you see a decimal, a really small decimal, that's always going to be a negative power. How do you figure out the negative power on the 10? Well, start where you want the decimal and count over to where the decimal actually is currently. 1, 2, 3, 4, 5. So this would be 7.82 times 10 to the negative 5th power. In a similar way, for big numbers, we'll have a positive exponent, and the way we calculate it is a similar way. 1, 2, 3, 4, 5, 6, 7, 8. So this will be 8.36 times 10 to the 8th power. Of course, we can also go backwards as well. So, if we wanted to write negative 9.36 times 10 to the negative 6 as an actual decimal, we would have that it would be negative 0. And now we need to calculate all of the decimals out. So we know the decimal went up by 6, so 1, 2, 3, 4, 5, 6. This is where the decimal used to be, so 9, 3, 6, but then we need to fill in the rest with zeros. Okay? In a similar way, here we move the decimal 1, 2 spaces down, and this is 134.5. Now let's have you try an example. Go ahead and try writing 45,850 in scientific notation and writing negative 2.718 times 10 to the negative 3rd in decimal notation. Again, go ahead and pause the video while you work this, and on the count of 3, I'll reveal the answer. 1, 2, 3. So now you can go ahead and check your answers. So let's do one more example. Let's evaluate this expression using scientific notation. So, as our solution, let's go ahead and we're going to go ahead and write each of these numbers out and then use our laws of exponents to evaluate it. Namely, this is 2.4 times 1, 2, 3, 4, 5, 6, 7, 8, 9 times 10 to the 9th. This is 4.5 times 10 to the 1, 2, 3, 4, 5, 6, so negative 6th. This is 3 times 10 to the 1, 2, 3, 4, 5, so negative 5th. And this is 1.5 times 10 to the 1, 2, 3. And now, all we have to do is combine things in the right way. So this is 2.4 times 4.5 over 3 times 1.5, which gives times 10 to the 9th times 10 to the negative 6th, 10 to the negative 5th, 10 to the 3rd. Here it's helpful to note that 3 times 1.5 is 4.5. Just a little computational trick, because now you'll be able to cancel those as it's a multiplication with a division. This will be 10 to the 3rd on top. This will be 10 squared, 10 to the negative 2, on the bottom. But we know that when we put that up in the numerator, we'll add the exponents. So this will be 2.4 times 10 to the 5th. Or, if you prefer, you could write it as 240,000. So now we'll go ahead and have you work an example. Go ahead and evaluate this in a similar way to how I did it before. On the count of 3, I'll reveal the answer. 1, 2, 3. So now you can go ahead and check your answers. This over here, I did just a reminder of how to do multiplication with decimals by hand. For more practice with working with scientific notation, be sure to see page A23 of the textbook and work problems numbers 2 and 31 through 38. In our next video, we'll talk about radicals and their properties.